The headlines blazed across screens worldwide, bold fonts, flashing banners, and breaking news alerts. Everywhere you looked, the story was impossible to ignore. Alien life confirmed, we are not alone. Social media feeds exploded with excitement as hashtags trended and comment sections filled with wonder and speculation. Why do these headlines grip us so tightly? Because the idea that we are not alone taps into our deepest hopes and fears, sparking imaginations and fueling dreams of cosmic connection. Proxima b, our closest exoplanet neighbor, just over 4 light-years away. A world that seemed to whisper secrets from the cosmos. But behind the dazzling headlines and viral posts, a crucial question remains: what's the real story behind these explosive claims? As excitement swells, one figure stands apart: the scientist, skeptical and searching for truth. The explosive story didn't come from NASA or a scientific journal. It started on a YouTube channel called Envision Space. Viral videos and sensational social media posts spread the claim like wildfire, with dramatic thumbnails and clickbait headlines. These platforms often value attention over accuracy, turning speculation into trending topics that prey on our hope to find life beyond Earth. But real science doesn't work this way. Genuine discoveries are announced through careful press releases, scientific conferences, and peer-reviewed journals, not viral videos. Peer review is a rigorous process where independent experts scrutinize the evidence, challenge the methods, and verify the results before anything is accepted as fact. So let's separate science fiction from scientific fact. Real discoveries are communicated with caution and evidence, not hype. When a breakthrough happens, multiple research teams confirm the findings and reputable news sources report the story with input from scientists. The rumors started with a real signal, BLC-1, detected in 2019 by the Breakthrough Listen project. This massive initiative uses the Parkes telescope in Australia to search for intelligent communications, and for a moment, they thought they might have found something incredible. What made BLC-1 so tantalizing was its nature. It was a narrow-band signal, a type not usually produced by natural cosmic sources. This is the exact kind of technosignature that could indicate technology, and it appeared to come from Proxima Centauri's direction. But here's what real scientists do: they don't jump to conclusions. The Breakthrough Listen team didn't hold a press conference. Instead, they got to work quietly and methodically, beginning the long and arduous process of trying to prove themselves wrong. Science is a journey of questions and evidence. When the BLC-1 signal was first detected by the Parkes telescope in 2019, it sparked excitement, but also skepticism. Scientists knew that extraordinary claims require extraordinary evidence. The first step was forming a hypothesis. Could this signal be a message from another civilization? Or was it something closer to home? Researchers meticulously gathered data, analyzing every blip and spike in the radio waves. They tested every possible explanation, searching for sources of interference: satellites, cell phones, even microwave ovens. Each possibility was checked and rechecked, with teams working independently to verify the results. Peer review was essential. Other experts scrutinized the methods and findings, searching for flaws. This process is the backbone of science, ensuring that only robust, repeatable results stand. In the end, the verdict was clear. BLC-1 was not a message from aliens, but human-made interference. The scientific method had worked. Skepticism and careful analysis revealed the truth. Proxima b, discovered in 2016, remains a real achievement in exoplanet science. It orbits in the habitable zone, where liquid water could theoretically exist. But science reminds us, skepticism is not cynicism, it's the path to real discovery. Proxima b orbits its star, Proxima Centauri, at a distance much closer than Mercury is to our Sun. This tight orbit means a year on Proxima b lasts just 11 Earth days, but its star is a red dwarf, prone to violent stellar flares that unleash intense bursts of radiation. These flares bombard Proxima b with X-rays and ultraviolet radiation hundreds of times stronger than what Earth receives. Such extreme conditions can strip away atmospheres and destroy complex molecules, making the surface incredibly hostile to life as we know it. Proxima b is almost certainly tidally locked, with one hemisphere in perpetual daylight and the other in endless night. Only a thin twilight zone between these extremes might allow for temperate conditions, but even there, survival would depend on a protective atmosphere and magnetic field. The term habitable zone simply means a planet could have liquid water, not that it does. Proxima b's harsh radiation, possible lack of atmosphere, and unknown magnetic field make true habitability unlikely. Infographics comparing Proxima b and Earth show just how different these worlds are. scientists are using powerful telescopes to search for signs of an atmosphere around Proxima b. By studying starlight as it passes through the planet's edge, they hope to detect gases like oxygen or methane. For now, the question of habitability remains open, and research continues. But what are scientists actually searching for when they hunt for signs of alien civilizations? The quest has evolved far beyond old-school radio signals. Today, researchers are on the lookout for technosignatures, potential evidence of advanced technology at work on other worlds. Technosignatures could take many forms: powerful laser pulses, unnatural patterns in starlight, or even the faint glow of city lights on a distant planet's night side. Scientists use an arsenal of cutting-edge tools, from massive radio telescopes like FAST and the upcoming Square Kilometer Array, to space-based observatories scanning for infrared heat that could hint at gigantic solar arrays or Dyson spheres. But this search isn't just about detecting a weird blip. Every promising signal is met with rigorous skepticism. Is it really from an alien civilization? Or just a stray satellite, a cosmic ray, or interference from Earth? The 1977 WOW signal is legendary, but decades later it remains unexplained, not confirmed. When a new signal pops up, the scientific community springs into action. Independent teams try to replicate the result using different instruments and methods. Astronomers dig deep to rule out every possible natural or human-made source. Only if a signal survives this gauntlet of scrutiny does it become a true candidate. So far, every technosignature claim has turned out to be a false alarm, a misidentified satellite, a software glitch, or a mundane cosmic event. But each false positive sharpens the search, helping scientists refine their methods and eliminate noise from the data. The hunt for technosignatures is a global, collaborative effort built on transparency and skepticism, not sensational headlines. It's a search for unmistakable, repeatable evidence that can stand up to the toughest scrutiny. Evidence that one day might truly change our place in the universe. Real science is slow, methodical, and built on evidence, not excitement. It's a deliberate process of hypothesis, testing, and analysis. This rigor is designed to build a case on a foundation of verifiable facts, ensuring conclusions are sound, not just sensational. Throughout history, the media has sometimes misreported or misunderstood major scientific discoveries. In 1996, headlines declared that a Martian meteorite contained evidence of life on Mars. The world was captivated, but later studies cast serious doubt on those claims. Or consider the faster-than-light neutrino announcement in 2011. Sensational headlines spread rapidly, but the result was later traced to a faulty cable. The scientific process worked. Extraordinary claims faced extraordinary scrutiny. Every claim must survive rigorous peer review and independent verification. Scientists challenge each other's methods, searching for errors, and demanding evidence. Only after repeated testing and replication does a discovery become accepted. This system of checks and balances is what ensures scientific integrity and accuracy. It's not about suppressing ideas, but about making sure only the strongest evidence stands. Clickbait thrives on false certainty, using bold emotional language for a reaction. Science, however, speaks cautiously with phrases like, "evidence suggests." This precision isn't weakness, it's the source of its strength and reliability, separating fact from fiction. The search for life beyond Earth continues, guided by evidence, not wishful thinking. Powerful instruments aren't looking for alien cities, they're hunting for subtle chemical clues in the light from distant worlds. This is a meticulous search for data, not drama. Future telescopes will analyze atmospheres for real biosignatures. They study starlight filtering through an exoplanet's air, looking for chemical fingerprints of life like coexisting oxygen and methane. But first, scientists must rule out every possible non-biological explanation. It's a generational endeavor requiring patience and scientific rigor. Like the decades-long search for the Higgs boson, finding extraterrestrial life is a marathon, not a sprint. It's the slow assembly of a colossal puzzle, with each generation adding another crucial piece. So here's the truth. No alien life has been confirmed on Proxima b. The headlines were speculation, not science. The leap from an unexplained signal to an alien civilization is a chasm, built on misinterpretation and a desire for clicks, not evidence. No credible scientific institution has announced such a discovery. Not NASA, not the ESA, not the SETI Institute. If there were credible evidence, they would present it cautiously with supporting data, not through a shadowy leak or a viral video. Proxima b remains a fascinating but likely hostile world. It's blasted by intense radiation from its star, and is likely tidally locked, One side scorched, the other frozen. It's a far cry from the welcoming haven some headlines suggested for alien civilizations. Our desire to find life beyond Earth is understandable and drives real scientific progress. That deep, human impulse to ask, are we alone? Is the engine that fuels discovery, pushing us to build better telescopes and ask bigger questions. This curiosity is a gift, but we must distinguish between hope and evidence, speculation and science. We must channel that curiosity responsibly by becoming critical consumers of information. Ask who is making a claim and where their peer-reviewed data is. Resisting easy answers is key to understanding. The universe may yet surprise us, but it will be through careful science, not viral videos. One day we may get the answer. That confirmation will be the culmination of decades of work, not an anonymous post. The truth is out there, and science is how we'll find it. As the dust settles on the headlines and speculation, the real story is just beginning. The search for life beyond Earth is entering a new era, one defined by patience, precision, and breathtaking technological advances. In the coming years, a fleet of powerful new telescopes will take humanity's curiosity to unprecedented heights. The James Webb Space Telescope, already peering deeper into the cosmos, is only the start. Soon, the European Extremely Large Telescope and NASA's Nancy Grace Roman Space Telescope will join the hunt, their gigantic mirrors and sensitive instruments designed to analyze the faintest glimmers of starlight reflected from distant worlds. These telescopes will do more than simply spot exoplanets. They'll dissect the light passing through alien atmospheres, searching for the subtle chemical signatures, biosignatures, that could hint at life. Imagine detecting the precise fingerprints of molecules like oxygen, methane, or water vapor, and then painstakingly ruling out every possible non-biological source. It's a slow, methodical process, but each data point brings us closer to the truth. New missions like ESA's Ariel and NASA's planned Habitable Worlds Observatory are on the horizon. Their specialized instruments will scan hundreds of exoplanet atmospheres, building a vast library of planetary fingerprints. Each discovery will be scrutinized, debated, and tested, sometimes for years, before any claims are made. Meanwhile, advances in artificial intelligence and data analysis are helping scientists sift through mountains of telescope data, spotting patterns and anomalies that might otherwise go unnoticed. The careful collaboration of international teams ensures every finding is checked, double-checked, and peer-reviewed before the world hears about it. The excitement isn't in the hype, it's in the possibility. We may not find alien civilizations tomorrow, or even in this generation, but with every new mission, every improved instrument, we're stacking the odds in our favor. The universe is vast, and our tools are finally catching up to our questions. This journey is a marathon, not a sprint. The discoveries of tomorrow will be built on the careful, patient work of today. And while science may move slowly, its progress is unstoppable. The next headline-worthy revelation might not be clickbait. It could be the moment we confirm that somewhere out there we are not alone. The adventure continues. The universe is waiting.